Good evening, everyone, and welcome again to the inaugural program of the Don and Jennifer Holsworth Climate Speaker Series. My name is Scott Dunn, and I'm the Community Programs Coordinator here at Walkie Mountain Science Center. I'll be moderating this evening's program. A quick note on engaging with us throughout the evening. We are going to be utilizing the Q&A feature at the bottom of your screen to ask our presenter any questions you may have, and then we'll be addressing those at the end of the presentation. So please utilize that feature throughout the program. I'm joined here by Don Holsworth, and I'd like to take a moment here for us all to get to know Don and Jennifer Holsworth a little bit better, as they are the generous sponsors of this new series. Don is an adjunct professor and executive in residence at the University of North Carolina's Gillings School of Global Public Health. He is also a board member here at Walkie Mountain Science Center and sits on the Board of Trustees at the Southern Environmental Law Center. Don and his wife are active organizers of a climate conversation series in North Carolina, and their philanthropic work focuses solely on environmental and educational organizations active in the fight against climate change and its impacts. So thank you so much for the support, Don. Thank you for being here this evening. It's great to have you here and get this series rolling. So thank you.
Yeah. Scott, thank you very much. I appreciate the opportunity to, first of all, say that Jennifer and I are very pleased to be able to sponsor this series. We think the topic is extraordinarily important. It's important to Walkie Mountain community. It's important to Eagle County and people across the world. Yeah. And I'm very pleased to be able to introduce Dr. Jason West, who's our inaugural speaker. Dr. West is a professor of environmental sciences and engineering at the University of North Carolina at Chapel Hill. He leads interdisciplinary research there, connecting climate change, air pollution, energy, and human health. And he speaks and writes publicly on these topics to many audiences. He is an engineer as well as a computer modeler with a PhD from Carnegie Mellon University, and has worked previously at Princeton, MIT, the U.S. Environmental Protection Agency, and the National Institute of Ecology in Mexico City. He is currently lead author of a chapter in the next U.S. National Climate Assessment and co-chairs an expert working group on global air pollution exposure for the World Health Organization. We are grateful that Dr. West is here to speak to us about the nexus of air pollution and climate change, and about some of the ways that climate change affects human health. Dr. West, welcome.
Thank you very much. Is it time for me to share my screen, or was somebody else first?
Before we dive into your presentation, Dr. West, I would like to first introduce our Senior Programs Director of Sustainability and our partner in this series, the Eagle County Climate Action Collaborative, to take a localized look briefly at what climate change means to us here in Eagle County. Alyssa, I'm going to turn it over to you.
Thank you, Scott. I believe you can see my screen. So I'm going to go ahead and share just a little bit about what's happening here locally. Hello, everyone. Just again, want to show you what's happening locally and what the future holds. So climate change is often, it feels like a distant problem. And the reports that come out often refer to global trend. We don't see sea level rise and hungry polar bears here in Colorado. But we are currently seeing, and we will continue to see the impacts here in our county and across the state. A study called the Climate Projections for Eagle County came out last year, and this slide is a snapshot of the study conducted by the Rocky Mountain Climate Organization. They looked at a few different emission scenarios illustrated by what you see on the far bottom left graph. And then they looked at the impact of those emission scenarios on temperature changes in 3 areas in our county: Edwards and Avon put together, Vail Mountain, and Eagle. The graph on the right shows how many days in Edwards and Avon that will be 85 degrees or hotter in 20-year increments. So the baseline is 1970 to 1999, with only 1 day a year that was 85 degrees or hotter. What I want to highlight is that if you look at the red bars compared to the other 3, yes, they're obviously taller, but they also have significant differences between each 20-year period. Large increases versus smaller increases in the milder emission scenarios. Here's a chart showing days that will be 32 degrees or hotter in the winter for those areas. And so what all of this leads to is a winter that warms up faster in the spring, generating a shorter and slushier ski season. We'll likely see more precipitation, but rather than a few intermittent storms, they'll occur in the form of infrequent but heavier storms. And we are currently seeing an increase in natural disasters as well as the threats to human health that they bring. So wildfires, mudslides, water quality issues from fires and pollution, fire disturbances, and public health problems for poor air quality. Just this last summer, we had mudslides that occurred from torrential rainfall and caused severe disruption when they shut down the canyon. And even at our center in Avon, we saw a lot of damage. In summary, yes, this outlook is gloomy and scary, but the point is to be realistic about what could occur if we don't have action. The best takeaway from this study is that reducing emissions helps to stabilize those temperature changes. Some damage is already done, so we will see temperature increases in the next 20 years. But as you can see, after that initial increase, there's very little change between the 20-year time increments. There's a lot to be done, but there's a lot of people in the county that are working on this, and we encourage you all to get involved if you can. So here's a glimpse of what's happening with climate action in the county. You could consider that the Climate Action Collaborative is just a drop in the bucket because it is global emissions that have to be reduced. But we as a county and a mountain community, we're going to make sure that we do our part and contribute as much as we can. The Climate Action Collaborative is a collection of partners around the county, businesses, local governments, nonprofits, schools, etc. We really want to implement actions that will help us achieve our overarching community climate action plan goal. Our plan was updated in 2020 to reflect the most current science, and as a result, the goal became a 50% emissions reduction by 2030. We have working group sectors for energy supply, buildings, waste, transportation, water, and carbon sequestration, and they are all working hard on the priority actions that you see on this slide, which will help us reach that goal. So if you'd like to learn more about these efforts, please go to climateactioncollaborative.org. And with that, I will turn it back over to you, Scott. Thank you.
Thank you, Melissa. And before we get started, I just want to thank you all for joining us again. Here at Walking Mountains, our mission is to awaken a sense of wonder and inspire environmental stewardship and sustainability through natural science education. And by participating in programs like this, you are all helping us fulfill that mission. And specifically with this program, you're helping us raise awareness and understanding around climate change and hopefully come up with creative action steps to combat it. And with that, I would like to turn the evening over to Dr. Jason West to share his insight and expertise on the issue as well. Thank you, Jason.
Great. Thank you very much for that excellent introduction. I'm very happy to be with you. There we go. I want to thank Don and Jennifer Holsworth first off. They've been extraordinarily true supporters of UNC and certainly dedicated to the cause of talking about climate change and moving toward action. We've done that through our public engagement group here in North Carolina, and I've really been impressed with what he's been able to do with the Walking Mountains Science Center, as well as others in Colorado. So thanks to them, and thank you all for joining us. It's important. This is an important topic, and most off, it's really important that we're getting together and talk about it. Good. So I'll set up our talk in a minute, but I wanted to share this picture. I've only been to Vail a few times, but this is one picture in Vail. That's our oldest son and my wife, who is then pregnant with twins. So we have 3 boys now. And this is right by, there's a playground with a big pirate ship in it. I'm sure you guys know it, but I haven't been there in years, but I remember it well. So I'm sorry I can't be there in person and speak with you all in person. What I'm planning to do today is to talk about 2 big, important, separate to an extent, but interrelated problems of climate change and air pollution. I'll talk about how these problems are interrelated with one another and how we can work towards solutions that will solve both together. Both are, I'll pose as local but global challenges. I'll talk about energy as the driver for these two big problems. And I'll talk about, for air pollution, the main impact that we care about is health. For climate change, there's many kinds of impacts that are associated with climate change that we care about, but health is certainly one of them. And I'll highlight some of the ways that climate change affects health. So I'll draw connections between these four big topics. I'm going to start off, though, by talking about air pollution as a global health threat. Let's start historically. Let's go back to the start of the Industrial Revolution here in England with the factory burning coal. Smoke might not surprise you. What might surprise you, though, is if we look what's next to this big factory are what looks like homes and businesses. And this is the way cities were back then. People, because they didn't have motorized transport very much, lived very close to where they worked. And it meant that people had extraordinarily huge exposure to air pollution from these sources. And that continued well into the 20th century, too. I'll show you a couple more pictures of air pollution. This is Donora, Pennsylvania in the United States. This was the worst episode of air pollution from a health point of view that the US has ever experienced. Donora is not a big town, but it had a big industry in it. That pollution from that industry, this was a noontime picture with the lights on, was so thick that you needed the lights on during the day to see. 1/3 of the town became sick over the course of 4 or 5 days of severe air pollution, and actually 20 people died. We can go to 1952 in London. Now a lot more people were exposed to very severe air pollution. Again, a daytime picture with lights on. And this is a measure day by day over the course of 2 weeks of how much smoke was present. These are rudimentary measures compared to what we have today, but I'll talk a little bit more about what this smoke means. And you can see that all they did then was look at day by day deaths in London. These were the deaths that you would expect, about 250 or 300 deaths per day. Over the course of this episode, now up to nearly 1,000 deaths per day. When we combine the information over this whole period, we think that about 4,000 people died from this 1 week long smoke episode. So it's been apparent for some time that very severe air pollution causes people to die early and other health effects. But it's also become the case that we understand today that even day-to-day air pollution, even in places where we think the air is relatively clean, also causes health effects. I'll go forward in time. This is Los Angeles. In the 1950s, a new form of air pollution came to our awareness, and Los Angeles was ground zero for that. This is what became known as photochemical smog, where ozone was an important component of that air pollution. And here we have these ladies are rubbing their noses and eyes because ozone is an irritant. Los Angeles had a sort of perfect storm, old vehicles that were emitters of nitrogen oxides and volatile organics. Also within Los Angeles were heavy industry, including refineries that were a big source of volatile organics. And there was plenty of sunlight in Los Angeles. The three together, nitrogen oxides, volatile organics, and sunlight combined to make ozone. So it became a perfect storm of creating ozone, and where we first learned about the ozone problem. Now we understand that ozone's pervasive throughout the world, but certainly worse in polluted cities. Going forward in time, the US started taking action to reduce air pollution, starting with the 1970 Clean Air Act, followed by the 1990 Clean Air Act amendments. And there's a lot of information on this graph, but you see lines going down for many different pollutants. We've cleaned up our air quite a bit. And one of the pollutants that's really noticeable here is SO2, which has gone down about 90% from where it was in 1990. And that was because of mainly smokestack controls on power plants and large industries. The other driving force here, it's really EPA regulations that was forcing these changes to take place. But technologically, what happened was we met these standards by putting smokestack controls on big industries and by putting tailpipe controls on motor vehicles. Another view of how much we've improved our air. This is really a extraordinary story. This is NO2, one of the pollutants that we care about that we can measure very well actually from satellites. And looking at a satellite view of the United States, it's remarkable how much we've cleaned up our air. This is a success story that's not talked about enough. Yet, even as far as we've come in cleaning up our air, we think that about 50,000 people or so die prematurely each year in the United States due to exposure to air pollution. So we still have a pretty significant problem. I want to introduce one of the pollutants that I'll be talking about, which is fine particulate matter. The measure that we use for fine particulate matter here is PM 2.5. You might have heard that term before. This is a human hair. Compared that to the size of a PM 10 particle, and here in red, a PM 2.5 particle. So PM 2.5 is all particles smaller than 2.5 millionths of a meter. If I take a cubic centimeter, that would be just the tip of my little finger, and ask how many little particles are in just a tiny volume of air like that, the answer is actually on the order of millions. Even in clean air, we have millions of particles present. Okay, and those particles have important effects on health. Let's look elsewhere in the world. So this is Beijing, and in a period that became known as the airpocalypse in China. It was front page news in the United States and many other places around the world. You see here a satellite image. These are clouds to the south here. This is the center of Beijing in this soup of air pollution. These are the mountains to the north of Beijing. You can see air pollution spilling out through the mountain passes, showing up as dark over the bright color of the snow. PM 2.5 during this period was measured at greater than 30 times the World Health Organization guideline. So a very severe air pollution episode. And this is what it looked like on the ground during that. This was back when the American public wasn't used to seeing people wearing masks, right? So, but they were in China to avoid severe air pollution at this time. Another place where air pollution is very severe is India. This is New Delhi. This would be a picture under smoggy conditions and then under clean conditions that were achieved through the COVID lockdowns, actually. And this picture made its way around the internet as a really striking visual indicating how severe their air pollution can be. When we look around the world, it's actually the case that the great majority of the world's population breathes air that exceeds the WHO guidelines for ambient PM 2.5. I've done a lot of work on ozone as well, and we've concluded that actually the same is about true for ozone. About 95% of the world's population breathes air that exceeds the WHO guidelines for ozone as well. And where does that air pollution come from? It comes from a variety of different sources, but about 71% of what people breathe comes from fossil fuel combustion. That might not be surprising to you. So power plants, industries, businesses that are burning fossil fuels for a variety of uses, motor vehicles. So together, these make up the great majority of exposure to air pollution that we have today. How many people die each year because of exposure to air pollution all around the world? We can get an estimate of that from the global burden of disease of air pollution. This is a big collective effort that I contributed to. My lab was the first to use computer models to simulate what people are breathing all around the world. And my lab produced the estimates of ozone air pollution that were used by the global burden of disease assessment. But here we have together PM 2.5 pollution, ozone pollution, giving us about 4.5 million deaths per year. There's a third category here, which is household air pollution from solid fuels, and I'll talk about what that is briefly. I used to do some work in Mexico, in very rural areas of Mexico, where I helped families that were far from the electrical grid get solar power. And this was a picture that I took there. The woman here, her name is Regina. She had cooked me lunch over this, and this is how she cooks every day, over a wood fire. This is a very small adobe room with no ventilation whatsoever, except for the door that we use to walk in and out. So throughout Mexico, throughout Africa, India, China, Southeast Asia, people around the world are cooking under these conditions, with especially women and children being exposed to extremely high levels of air pollution for hours and hours a day. Okay, and that's what's shown here. The estimate there is an additional 2.3 million deaths. Together, this makes up 1 out of every 8.5 deaths in the world. And one of the nice things about the Global Burden of Disease assessment, they looked at air pollution as a risk factor here, 6.7 million deaths, and compared it to a lot of other risk factors. And you might be surprised to see that air pollution is as important as things that we generally understand and accept are really important for our health. So high blood pressure, tobacco use, dietary risks, diabetes, obesity, and there is air pollution in the mix. And you might notice as well, it is the most important environmental risk factor for global human health, the most important environmental risk factor. Okay. To put it into a little bit more perspective, if we take this number of 6.7 million deaths, or 1 of every 8.5 deaths globally, how would you think that that would compare to other causes of death that I've listed here? You might be surprised if I told you that air pollution is actually number 1 on this list, that it kills more people than any of these other causes of death. But in fact, it's actually as important as a cause of death as all of these 7 causes of death combined. So together, these 7 causes of death give 6.7 million deaths, and that's equal to what we get from air pollution. So pretty striking numbers. And one of the important things is that we didn't actually know that air pollution was this important for health on a global scale until about a decade ago. And I was proud to have played a role in helping to generate these numbers. Okay, that's what I'll say as introduction about this global problem of air pollution for human health. I'll turn our attention a little bit to give a short introduction to climate change. And I don't want to belabor this because I know that many of who are listening in here today have heard about climate change before. But I want to highlight some of what's new in the science around climate change. So I'm drawing information from the new IPCC report. This is the Intergovernmental Panel on Climate Change that issued its new report last year. These are thousands of scientists around the world that contributed to this document. And I am a contributing author for the next volume of the IPCC that will come out later this year, that looks at the impacts of climate change. To look at some of the words that IPCC used here, they said it is unequivocal that human influence has warmed the atmosphere, ocean, and land. For scientists, this is a very strong statement because we tend to hedge our bets, right? We tend to use uncertain language, but unequivocal, there's nothing equivocal about that. And they're saying that human influence is what has done that. How much has the Earth warmed? This black line shows you the observed temperature record, bringing us up to today, with the last decade being the hottest decade on record. We've warmed from the late 19th century by about 1.1 degrees Celsius, that's 2 degrees Fahrenheit. And some places have warmed more than others, but as a global average, that's how much the world has warmed. As you can see in this picture then, the group of scientists involved in this report used computer models to simulate if there was only natural forcing. So looking at this changes in the sun's output, looking at volcanoes that erupted that cooled the Earth for a few years, you have no way of explaining this rise of temperature. But if you look at human influences together with natural influences, now we can explain this temperature rise, especially that's happened in the last 30, 40, 50 years or so. Okay, so it's likely that actually all of this observed temperature rise that we see here can be attributed to human activity. Another thing that the IPCC concluded, they looked at extreme events, and they said that human-induced climate change is already affecting many weather and climate extremes in every region across the globe, including heat waves, heavy precipitation, droughts, and tropical cyclones. And here are just a few pictures of that from the United States over the past year or so. Okay, so we have an increased ability now to understand what is the effect of climate change to make these weather extremes more frequent or more severe. And we're able to partially attribute those weather extremes to some influence of climate change. When we look at the future then, we don't know what the future will be like. We might take a pathway where we're taking strong action to reduce emissions. We might let emissions grow without taking strong action. That leads then to a range of scenarios given by these different colors here. In the most optimistic from a climate point of view scenario, we stabilize temperature change. So we've already gone up, as I said on the last slide, about 1 degree Celsius, that's 2 degrees Fahrenheit or so. And we would continue to warm, but we would eventually stabilize climate change and turn the corner toward returning back to where we were, versus a future where temperature change increases quite a lot. And these two red scenarios might indicate possibilities of how severe that temperature change would be. 4 degrees Celsius here would be about 7 or 8 degrees Fahrenheit, so globally averaged by 2100. By the way, I'm planning to still be around in 2100. I don't know if you are, but 4 degrees Celsius, 7 or 8 degrees Fahrenheit, that's a pretty big change. If we look at the right here, we can see what emissions would be needed to achieve these different scenarios. And in the red scenarios here, we have emissions. This is global emissions of carbon dioxide per year in the present day. In this red scenario, it's going to triple or so over the course of the coming century, versus the blue scenarios that start decreasing right away and get us to actually zero emissions or even net negative emissions, where we're pulling CO2 out of the atmosphere that we've already put there. So quite a range of different scenarios are possible, but the important messages, I think, are what I say at the top here. The extent of future warming that we'll see is within our control. We can achieve these scenarios relative to these ones. And that global warming will only stop after emissions will go to near zero. So we need to have emissions close to zero here for the long time scale of the Earth to respond to it, to suck up some of that carbon dioxide naturally into the oceans and into the plants of the world. And even in these red scenarios, there's no suggestion that global warming will stop at 2100. It will keep getting worse until we reach the point where we've drawn emissions down to near zero. Okay. To help understand this, I like this website. It's created by a group called Climate Central. You type in your city where you live, and I entered Denver. And it says by 2100, summers in Denver, Colorado, which are today 85 degrees Fahrenheit on average, will be like summers now in, and it looks up the place in the world that matches what your climate's going to be like. And I should say this was for the most extreme red scenario that I showed you on the last graph. And that is deep South Texas at 97 degrees Fahrenheit. I'm going to guess that those of you who live in Vail choose to live there and not South Texas for a reason. And I'll let you fill in the gap of what that reason is. But if you're interested, I looked up other places. This is average daily high temperature in the summer. Today in Boston will be like what North Miami Beach, Florida is, and so on. Okay, so that helps to visualize how severe and how abrupt these changes in climate are expected to be if we don't take action. Okay, some of the other influences of climate change have to do with precipitation, and I've illustrated here some of those effects. So we've got here the climate of the past, with rain somewhat evenly spread out as we look at a calendar. And as we look at the future, then, this is exaggerated, but it makes the point. We're expected to have fewer rainfall events, but when rain falls, that rainfall is expected to be more severe. In general, there's going to be places that will get wetter. Other places will tend to get drier. We see the Western United States today in a severe drought that's likely to be an effect in part of climate change. But even a place that has annual average rainfall the same, just changing from this picture to this calendar for the future where we have less rainfall events, but those are more severe. Now we've got greater risk. We've increased the risk of both droughts and floods in the same place. Hope that makes sense to you. Okay, so that might help to illustrate. What are the impacts of climate change that we care about? And there's many of them, and many of them are ones that you've read about or thought about before, and I don't need to go over this list. But when I want to take a minute and talk about human health, and human health, impacts of climate change on human health is itself a big, challenging topic because of the many ways that climate change influences human health. And I've listed some of those here. When looking at the impact of climate change on human health, this is what some of the leading scientists, public health scientists and medical scientists around the world came to conclude. So in a major study that was released in 2016, they said that tackling climate change could be the greatest global health opportunity of the 21st century, not curing cancer, not stopping infectious diseases now that that's on all of our minds, but actually slowing climate change is what they said. This is Vivek Murthy, who is once again our Surgeon General. And in response to a release of a report that was focused on climate change and health in the United States, he said that this was more challenging to public health than the polio epidemics. This is a new kind of threat. And he said that because of the many different effects that climate change has on human health. Where in the country do we expect the greatest impacts of climate change? There was a study that was released a few years ago where they looked county by county at economic damages of climate change, accounting for impacts on coastal regions, impacts on health, and impacts on agriculture and a few other things. So not accounting for all possible economic impacts of climate change, but you can see the pattern is really pretty easy to tell. It's the ACC and SEC, right? Moving into the Big 12. Pac-10, where you are, looks pretty good in comparison, where some places might actually be better off economically. But this is really concerning. This is a loss in Georgia here in some counties of a quarter of the economic output of that county attributable to climate change by the time we get to the end of the century. So severe impacts. And you might notice from a political point of view, the states that are most resistant to doing something about climate change, it turns out, are those that are perhaps the most vulnerable to suffer damages from climate change. Okay. Another impact of climate change is wildfires, and you all are living this on a month-by-month basis where you see wildfires locally or you experience smoke. This was one of the severe episodes of wildfires that happened in California, with smoke being blown over many states here, right? You can see it visibly. It's actually been the case that when scientists have looked at where does wildfire smoke cause the greatest human health impacts, even though most wildfires now are in the Western United States, the health impacts are greatest in the Eastern United States, because of the smoke that blows from the west to the east, in addition to the much smaller fires that we have in the east. So you might be surprised to see that. What's driving this? It's one of the most profound droughts and prolonged droughts that we've had. This is just a snapshot of it, where this is in red here, extreme drought, in deep red, exceptional drought. This is really remarkable that we're using these terms to describe drought. This is a snapshot from this summer. If you look over different months, you would see different places highlighted a little bit as rainfall patterns will bring rain to relieve some of the drought in some places. But this is really an exceptional drought that has lasted now a decade. This is Lake Oroville last summer in Northern California. The hydropower facility there was turned off because there was not enough water to make it run. Okay, so I'll come toward the end of my talk here, and I want to make these connections between these two big problems that I started off talking about: air pollution and climate change. This is where I've done a lot of research. So we've done research on to what extent air pollutants like ozone and particulate matter affect the climate system. We've done research on the opposite influence. As climate changes, how does that affect air pollution? And fires is one of those very important influences. It's turning out, as we see from California and the Western US, but also as we see in Australia, for example. But what I really want to talk about here is this third connection, that actions to reduce greenhouse gas emissions also reduce air pollutants. So the main sources of greenhouse gases is fossil fuel combustion. And as I mentioned before, that's also the main source of air pollutants that cause this global burden of air pollution on health that I mentioned to you before, that is really still underappreciated, but it's good that we're talking about it today. Okay, so I want to talk about that a little bit more, but in order to do that, I want to put that into some context. So where do we get our energy from if energy is the driver of these things? And this is a historical look at that. And I think many people in the US population or around the world don't really appreciate what this figure looks like. You might know that our economy was driven by wood as the main fuel. So that's here in red at the bottom. But in doing that, we had deforested most of the United States by 1900, or at least the Eastern United States by 1900, because we needed that wood for energy. That became replaced by coal, as you see here, and this is the growth of coal. Later on, then, coal is now used mainly for electric power generation and in large industries. That then in the period after World War II, we started getting more petroleum, more oil. That's used mainly as a transportation fuel. Here's natural gas, and these little wedges up at the top give us some carbon-free sources of energy, of water, hydropower, nuclear, and then renewables of wind and solar. So as a percent of the total energy mix, these are the clean ones up here, but it's still got a long way to go if it's to replace all these. And just to be clear, burning coal, burning oil, burning natural gas, all of them release CO2 into the atmosphere and drive climate change, as well as being a major source of air pollution. Okay, so one of the studies that I want to just take a minute and talk about was a study that we did in my lab, where we looked at what if the world took climate change very seriously. Look at the effects, look at the drivers of greenhouse gas emissions and impose a global, very aggressive policy to slow down climate change. And we asked the question, what would that do to air pollutant emissions? What would that in turn do to air pollutant concentrations and human health? And we showed that this suite of policies applied all throughout the world would avoid air pollution related deaths by about 500,000 deaths in the year 2030. By the time we get out to 2100, avoiding 2 million deaths a year. When we put a dollar sign associated with that, so monetizing this health benefit here in 2030, this is in the United States in a range of $70 to about $500 for each ton of CO2 that we reduce. In China, it's greater than that because many of the actions we would do in China would be to move away from coal, and coal's the dirtiest. from an air pollution point of view, and there's a huge population exposed to that air pollution. Or as a global average, we get these numbers. You can compare these health benefits to the costs of controlling greenhouse gases, which per ton of CO2 reduced are somewhere in this range of 0 to 33. Here we showed that the health benefits just of improving air pollution from these actions exceed the costs of the actions in the first place. Okay, and this work got a lot of attention and we were really proud to have led it. Okay, let's take a look though historically. So I showed that if we take action to reduce greenhouse gas emissions, that's very beneficial for air pollution. Let's look at historically at what has happened in the United States. I've shown you before that we reduced our air pollution. Here, this is just one measure of that, but I showed before that we reduced several different air pollutants by quite a sizable percentage. So this is a real success story. We haven't done it by slowing the economy, by people driving less, by having less population, so population has grown, and those people are using more energy, so where energy consumption is increasing. And as a result of this energy increase in energy consumption, CO2 emissions have also gone up. So we've taken action to reduce air pollutant emissions, but that hasn't had this benefit of reducing CO2 at the same time. We can actually see the same thing if we look at China over the past few years. I showed you the Beijing air apocalypse, which happened in 2013. And then the years since then, China, to its credit, have been very aggressive at reducing air pollution, showing here SO2 emissions going down, being cut by over half over the course of 5 years or so, a remarkable decrease with many, many thousands or millions of lives saved as a result of this. But as air pollutants shown here have gone down, CO2 has gone up. And of course, their economy has been booming. So again, how has this come about? It's been through smokestack controls on large industries and power plants, not by reducing the use of fuel in those power plants. And so we see CO2 has gone up because we're taking actions that don't move away from fossil fuels. So we have this picture that taking action on greenhouse gases is beneficial for air pollution, but the opposite of taking action on air pollution has not historically been beneficial for reducing greenhouse gases. But that picture is changing, and this is where I sort of want to leave you today. This is the cost of electricity generation in the United States. Lazard is a consulting firm that creates these figures every year. They look at generically what we need to, in terms of cost to generate electricity using different technologies. Here's coal. Cost is pretty stable. Natural gas is now cheaper than coal. It's in part replaced coal because natural gas is cheaper to generate electricity. Nuclear is expensive in comparison, but the big story here is look how much solar costs have decreased just over a decade by 90%. We're at 10% of the cost we were looking at a decade ago. Wind costs have decreased as well. So this is making it possible to think about in a way that was only theoretically possible, but not maybe politically practicable, to think about switching wholesale away from fossil fuels toward these cleaner energy sources. And we see that happening. This is electricity generation in the United States. Coal use is decreasing, being replaced by natural gas, which through fracking has become cheaper. But the big story here is, even though it's small, the renewables, being wind and solar, are the fastest growing energy source that we have. And that's likely to continue, but should be, I would say, accelerated because of the importance of getting us off of fossil fuel from a climate point of view and from an air pollution point of view. Before I end, and I'd be happy to take your questions in a couple minutes, I want to look back at this COVID case, because I think there's a lot that we can learn here, and maybe this will spur some of your questions as well when we think about the climate change problem that we face. We can learn many things. So both have this, COVID is sort of a case study in to what extent do public and and policymakers trust science. And it's been, to me, really disturbing to see the distrust of science be used as a political weapon. We have this case where early action is better than reaction. So if we're hoping to avoid people dying from COVID, we need to take action well before we find people showing up in hospitals, right? Because the exposure took place weeks before they show up in hospitals. And the same is true with climate change. It's just a longer time scale. So if we want to avoid hot temperatures far in the future, we need to start taking action today, because it's a decadal time scale rather than a week one for climate change. There's also this case that's emerged that socioeconomic disparities increase vulnerability. In the case of COVID, it's people that can't afford to take time off of work to quarantine when they should be, that are one of the drivers of the problem. Similarly, when we look at hurricanes striking Louisiana, for example, people are unable to evacuate because of socioeconomic disparities, because they don't have a car or because they can't afford a tank of gas to get out. But one of the points that I want to emphasize here is this question: what happened during the lockdown? So we were all staying home for a while. What did that do to global emissions? And you can see that here. So this pandemic year, 2020, global greenhouse gas emissions have been growing pretty steadily. And now the pandemic year, we decreased by about 5%. But we're expected, numbers aren't final yet for 2021, we're expecting basically to rebound from that. This 5% decrease won't really mean very much at all from a climate point of view. And you might think, wait a minute, I was home all the time. I didn't go anywhere. And so why are we still emitting so much CO2 if that was the case? And of course, in China and India, there were severe lockdowns like there were in the United States. And it's because the energy is sort of baked into the system. We need, part of that energy is to heat and cool buildings, even if we weren't going into our offices, or to manufacture products that we use. And that just didn't stop. And so I'll phrase it this way: staying home was never the solution to climate change. Rather, systemic changes that change our sources of energy use are. So it's not this sort of, actually, to me, is good news. It's the solution to climate change is not to beat people over the head until they change their light bulbs or drive electric cars. The solution is to change the electrical system so that the electrons going into their homes comes from clean energy sources. Ultimately, that'll be what will get us the furthest, the fastest. Okay, so to conclude, again, the big picture was I wanted to relate climate change and air pollution, these two big problems. So for climate change, we have this problem. We need to reduce greenhouse gas emissions to near zero this century. How do we do that? By getting off of fossil fuels as an important energy source. We will never get down here if we're burning a significant amount of fossil fuels. So renewables or other ways like nuclear are ultimately the solution. From an air pollution point of view, I mentioned before, we have these new World Health Organization guidelines on health, where they looked at the evidence on how air pollution affects health. And the new guidelines are so tight that many cities around the world may not be able to meet those if there's much fossil fuel use at all, even if we're controlling emissions from the tailpipe of cars or from putting smokestack controls on power plants and large industries. We just can't get to those levels, low levels of air pollution, if we're burning much fossil fuels. So both these two big important problems, the solution that's shared is let's get off of fossil fuels. So a few thoughts just to wrap up. Air pollution, I'll say, has been a 20th century plague that continues today into the 21st century. We've taken great action in the United States, also in Europe, to clean up our air, but it's still a problem. We're still above those WHO guidelines. And air pollution continues to get worse elsewhere, such as India and Africa. Taking action to reduce greenhouse gas emissions will bring benefits to air pollution and health, and we showed that those benefits can actually exceed the costs of the actions in the first place. Historically, when we've taken actions to reduce air pollution through smokestack controls, those have had little effect on CO2. But the big point here is that climate change and air pollution can both be solved by moving rapidly toward renewable energy resources and moving off of fossil fuels. So I'll stop there. Thanks for your attention. I'll be happy to take your questions.
Thank you so much, Dr. West, for sharing that with us all. We got a lot of good feedback in the Q&A. We have about 30 minutes left for this discussion with Dr. West. So please, if you haven't already, make sure you pop your question into the Q&A at the bottom of your screen. But I'm going to turn it over to Don to ask our first question for the evening.
Yes, some really great questions. Thank you all for posting those and keep them coming. So Max said, Dr. West, excellent presentation. Thank you. You'll appreciate this. You mentioned at the outset that you have 3 children. My son asked me one day after a tour of Flux Glacier in New Zealand, quote, why is your generation ruining the earth for our generation, unquote. What do you tell your children about their future earth? What do you tell them our generation is or is not doing to mitigate our carbon fuel addiction?
Great question. I'll give you a cop out, which is my kids are young enough that I haven't had that conversation. But I think making people feel bad about it is not going to help us too much. Making people feel hopeful that we have solutions is a good thing to do about it. So when I look at my father's generation, folks that are older than me, you're all lovely people. We know that you didn't do this on purpose. But we've also had awareness that this was a serious issue going back to the 1980s or so. And we've had plenty politically of opportunity to do something and get our act together and take significant action. And, through many international negotiation meetings, we've had the Kyoto Protocol, and now the Paris Agreement, where we've taken steps in the right direction, but there's been impediments along the way. I think really dwelling on the past is we can learn from the past, but dwelling on it and feeling bad about it is not going to get us too far. But feeling hopeful that we have the solutions technologically available. I didn't even mention electric cars today, but a lot of things available that we can move in the right direction. And let's use that to motivate us, old and young alike, to talk with people in Capitol Hill to make the right decisions that we need to make to move this problem toward a solution.
All right, great, thank you. And this one is sort of related. I think you answered maybe the first part of the question, but this is from Brittany Parker. Knowing all that you know, how would you avoid despair? And what can we do to reach those who would ignore a talk like this simply because it includes the words climate change? And I just wanted to point out that in March, our last speaker is Susan Joy Hassel, who's going to talk about communicating climate change. So Jason, what would you do to reach those who would ignore a talk like this?
Yeah, well, it's such a challenge, and our world is so polarized, and it didn't used to be that way. I'll sort of mention, if we think back to the days of the first President Bush, he understood the science of climate change. He never questioned the science, and he didn't quite take the action that I would have hoped that he would have from a climate point of view. But it wasn't because he didn't understand the problem. Now we're in this case where we're still fighting over what is the problem, and that's not really what the argument is about. The argument is about people who have aversion to what they see as the solutions, of big government being the solution, et cetera. It's solution aversion. It's not a fundamental problem with the science, which is we don't know everything about the science, right? I wouldn't claim that there's not more to learn, but I've been studying this problem for going on 30 years, and what I understand today about why is it an important issue. What are the actions that we could take to alleviate the problem? that really hasn't changed in 30 years. So how do we break down those barriers? I think Susan, you're right, Don, will be an excellent person to ask that question. But part of it is finding common ground. And if I was to talk with a group of, let's say business leaders that are swinging conservative, I would not put climate change in the title. I would talk about our energy future and then come in through the back door of, by the way, all this energy has an important implications for climate and for air pollution too.
And here's a more of a science question from Stephen Dowdle. It appears that there is no climate computer model that is predictive, despite scientists predicting all kinds of global warming and other global influences. In fact, there is no climate model that can look back in time and explain what has occurred on Earth's climate. It seems modeling the effects of clouds and moisture in the atmosphere is a major obstacle in modeling. I'm interested in your opinion. I am 100% a proponent of EV, electric vehicles, in urban areas, despite the environmental degradation that occurs in mining rare earth elements necessary for EV batteries. A great question for a modeler.
Yeah, great question. I agree. Yeah, there's a lot. There are uncertainties in the science, meaning that we can improve it. But these models, we get a test of them every day. The global models that we use to look at climate change are very fundamentally like weather forecasting models. And many of you would have the experience over your lifetime of just seeing how much better our weather forecasts are. They're never perfect. But we do a better and better job of it. When you said that climate models haven't looked successfully at the past, you're in part right in that, things like understanding the shifts into and out of ice ages, that's pretty challenging. I think we understand scientifically what's going on to a big extent. We have what seem to be pretty good explanations for the shifts into and out of ice ages, but quite modeling it successfully, we're not there yet. And part of it has to do with how is the biosphere, how is the natural world responding as climate changes. Where we have done it successfully, though, is simulating the past 100 years. And I showed that briefly in my talk. We can actually understand with pretty good precision how climate has changed in the past 100 years, not just the magnitude of that change, so the global average temperature, but also the spatial pattern of that. If we look at the spatial pattern around the Earth's surface, where is it getting warmest the fastest? If we look in the vertical through the atmosphere too, how is the upper atmosphere changing relative to the lower atmosphere? We have an ability to explain all of what we're observing there. Not perfectly, but to my mind, completely satisfactorily, in order to be supporting the conclusions that we're making about projecting future climate change.
Okay, so here's a question. Essentially, I asked you last night when we were reviewing your slides, and I had an answer, but I'm not sure if you agree. Can you comment more on the U.S. economic map you shared? While the economic conditions seem more favorable in Colorado for the future, wildfires cause significant air pollution in the western United States, which seems it would affect the economy negatively. Excuse me.
Yeah, good point. So that again doesn't have all possible influences of climate change baked into those figures, but it does have some major ones. So it doesn't have the effect of climate change to affect fires, to affect air pollution, to affect health. That's not in those. But it does look at heat stress mortality. It does look at losses of agriculture. And the main reason why we see it in the southern US and southeast US, the biggest economic impacts are because these places are already heat stressed, whereas the northern United States is not. And we could have possibly, in Minnesota, longer growing season could be good for agriculture locally. But in Georgia, that's not the case. And so that's why you see the differences that you do. So, and if we take that and extrapolate globally, it's Africa that's going to suffer because they're already heat stressed, right? Or India or Pakistan, and it's not Russia. Okay.
So, oh, there's so many great questions here. This one is really interesting. Volcanism and sun flux are thought to be the cause of the little ice age from about 1300 to 1900. Could these occurrences happen again and at least temporarily offset global warming?
Yeah, good question. So the little ice age was kind of around the period in Northern Europe when there was this expansion and, you know, the Vikings were going to Greenland and things like that. So you would have heard something about that before, many of you. I'm sorry, that would be the warm period after the ice age. But so those changes have happened in the past. One thing that we've learned, though, is the little ice age was not a global phenomenon, nor was the warm period that happened after it. It was really locally to Northern Europe and to the Northern Atlantic. And we don't have evidence 500, 700 years ago that the same changes occurred on a global scale. So could that have, one of the reasons we think that that was important could have had to do with ocean circulation. So the oceans naturally bring warm water up to near Iceland, and that keeps Northern Europe much warmer than would otherwise be. There would be many fewer people living in Scandinavia, for example, if they didn't have that ocean current. There might have been a slowdown naturally of that ocean current that brought that heat up. The causes that you're suggesting of volcanoes, we know what volcanoes have erupted through time, either from direct observations, people seeing it, or if they were in remote locations, we can look at buildup of volcanic ash in sediments. And we don't think that there was a big change of volcanism that far back. The sun's output goes through cycles, but it really hasn't shown a big influence, certainly in the last couple of hundred years, and we don't think in the 1,000 years or so before that. Okay.
Great. So our courier wants to know, what is your perspective on how the collaboration needed among all the leaders and organizations can actually happen to overcome the ignorance about the reality that you are presenting and the need for action, embodying the axiom, think globally, work locally, act personally. We need tremendous deliberate action.
I would agree with that. But you know, what gives me hope in part is not, as I said before, that we need to convince every individual to take action individually. Okay, those of you, I have solar panels on my house, I know Don does. Those of you who are doing that, bless you, thank you. It's great to be a leader in this area, but we don't need everybody to do it. To look at COVID again, you know, unfortunately in that case, we need people to be wearing masks. By the way, I talked about fine air pollution, the little particles. We understand that those little particles that cause air pollution are what carry the coronavirus in an indoor setting especially, and that's what is mainly responsible for transmitting the virus. And so that's why wearing a mask is so important, but I digress. So there we really need everybody to be taking the right action, vaccinating and wearing masks, right? In this case, when we think about climate change, it's not necessarily the case that individuals have to do it. If the right systemic changes are made, we're building electric vehicles, we're making them better, cheaper, faster than conventional vehicles, they will naturally replace, they'll drive internal combustion vehicles out of the market. If we provide clean electrons going into people's homes rather than ones that come from dirty fossil fuel sources, the homeowner doesn't even need to know that that's happening. But what we do need is majority of Americans, and we actually have this majority of Americans, polls tell us, where 60% or so of Americans will support stronger action to reduce greenhouse gas emissions and to take the societally important steps that we need to solve the problem.
Speaking of electric vehicles, we've all seen, this is from Michael Wurtzel, we've all seen the photos of cities from across the world during the COVID lockdowns and how clean the air quality was. You showed some pictures yourself. If everyone drove electric cars, would that cut down on the smog in places like LA and Denver so we could regularly see those beautiful mountain views from downtown in the middle of the summers?
In the US, transportation is a major source of urban air pollution in most cities, yes. If we look